Hello and welcome to the second session of Python programming for beginners, and today we'll discuss about operators and expressions in Python. So let us start with the arithmetic operations. Mostly we'll focus here for arithmetic and logical operations, and here is the list, the common list of the operators supported in Python. So we already acquainted with the operation like addition, subtraction, multiplication, division, remainder. Okay, so the two things additional operators that is supported in Python are the integer division and exponent. Okay, not all programming languages support exponent operation. They generally provide library function to calculate exponent, but here we have an operator to calculate the exponent. So or you can say power of a power a to the power b. All right, and in addition to exponent we have what is called integer division. Not all the time we need to have a division operation where we need fractional part. So we need to perform integer division where we are only interested to know the integer part of the division. So for that we can use integer division. Okay, here is the example. So a single slash indicate the true division, or can say floating point division in Python. So suppose you do 19 by 3, so it is going to result 6.3333. All right, but when you do 19 double slash 3, so it is going to integer. So the quotient will be an integer, a whole number, instead of any fractional part will be truncated. All right, so this is the list of arithmetic operator. And order of operation, when we apply this is also applied to the Python in the order first parenthesis, then exponent, then multiplication, division, remainder, all in the same level, and the lowest is plus and minus. And this is the order of precedence. Okay, parenthesis is the highest, that's the lowest number 0, exponent 1. The multiplication, all divisions and modular has precedence 2, and plus and minus 3. Now let's see, here is an example to demonstrate how they work. Okay, so it actually works like that it scans from left to right. First clear the parenthesis, then evaluate the exponent from left to right, then evaluate the multiplication or any division or modular operation from left to right if they are present, and finally the addition and subtraction. So here, taking this example, the first example, first we have a parenthesis here. So anything within the parenthesis is going to be evaluated first. So the expression a plus b will be evaluated first, resulting in a value 3. Okay, then we have exponential operation here, e to the power a, so 5 to the power 1 resulting in 5. Then the highest precedence is multiplication, so the 5 multiplied with b, okay, so it will be resulting in 10. So we have 7 minus 10, the 3 minus 10 resulting in minus 7. So this is how the order of arithmetic operation is applied in any arithmetic expression. So here one more example which shows that what is the impact of parenthesis in an arithmetic expression, where so 1 plus 2 star 3 indicate, okay, that first multiplication is applied, then addition resulting in 7. But suppose we insist that 1 plus 2 to be evaluated before any other expression, so we put them in the parentheses. All right, so the result will be different. Okay, so that is the how parentheses can change the order of evaluation of the operators. So, and if you have multiple parentheses or nested parentheses, the innermost parenthesis is going to be evaluated first. Now Python is also known as a dynamic type language. Why? The same variable can be associated with the value of different type during the program execution. Okay, and it is also very dynamic because it rarely uses what it knows to limit the variable usage. Okay, it is the new thing which was not there in the previous programming language, simple programming language C, C++, Java. Okay, so a same variable can be used to store any type of data. That makes it dynamic type language. Okay, so at the here we see an example, variable equal to 12, yes, and then we can also say a variable equal to 12.45, yes, true, variable equal to hello, true. So here 12 is integer, 12.45 is a floating point number, hello is a string, all can be assigned to the same variable var. This is possible in Python. So a same variable can hold any type of data. So there is no restriction that a variable which has been assigned a value can hold only one type of data, exactly one type. So any type of data, and we'll see once we learn the derived data types like list, tuple, and set, we can see that the same variable which is holding primitive type data like integer or floating point number can also hold a list, can also hold a set or a tuple. That is also possible. So there is no restriction at all. That's why we can also say that it's a dynamic type language. Next, one more important thing we must learn, okay, during value assignments or during the learning the expression, is that an ID function. It really indicates that, okay, how Python stores the value. All right. So we'll show this by a demonstration here. Okay. Let's say I start with a variable x, been assigned 10. Then let's say y equal to 20. So ID of x, okay, so ID of x indicates a unique number which has been assigned to a value. All right, so you can see that ID of x equal to 109.14784. all right, then we can see what is the ID of y. Okay, ID of y is 5104, different. Okay, so both have different values. Okay, so now let us see that we'll make it y equal to 10. We reassign y to 10, and let us see what is the ID of y. So ID of y changes with the value. Okay, the value you assign to it. Now the ID of y becomes equal to the ID of x. So what it indicates? Okay, so both had initially different values. Now I assign y equal to 10, which is equal to the value of x. So the ID becomes, so this indicates that once a value is assigned to a variable, okay, and it is only stored once, an instance is created only once. Next time each variable going to hold the same value, the variable is only referred to the old value. Okay, so that means for ID, a new for y, when it is holding 10, no new ID is created. Rather, the y becomes an alias of the value 10, whatever been holding my other variable. So ID of y becomes the same as the ID of x. All right. So this is how it works. Let's see another example. So ID, let's say x. Let us change it now. Okay. So ID of x equal to, now let's say we will make x equal to hello. Okay. So now ID of x must change. All right. Okay. So let's do another thing. Let's say z equal to hello again. So according to this, hello is already been created, okay, with this ID. So every time now z is holding the value hello, that means z will have the same ID as x. Okay, nothing but the ID of the hello. So every value, every constant has a unique ID. So let us see the ID of z, and this will be same as the ID of x. Why? Because it is holding the values hello. Now let us do one more thing, that let's say q equal to 20. Fine, possible. Now what will be the ID of q? Now q is holding a value 20, which has been already been created and stored. So that is initially when we created, you see that y equal 20. All right. So that time, what is the ID of the 20? So 109.15104. All right. So any new variable which holds the same value will have the same ID. So let us check. Let's verify whether q has the same ID, and yes. So it indicates, or we can conclude from this, that every time a new value is created, okay, then only we'll have a new ID. Not every time a new variable is created to hold the same old value. Alright, so every value has a unique ID. So every time a new variable holds the old value, it is nothing but a referred, or we can just become an alias of the old value. That we can summarize from the. So that is the use of id function to know what is the unique id of a given value. Okay, so here is an example given for as an exercise. You can try it to know more about how id works. Okay, so we can say that it's stored only once. Okay, and every time anything else points to one will be a reference, we can say a reference to that particular memory location, not that every time a variable holds the same value, a new location is created to store the same. So Python do not store duplicate values in the memory. Okay, it stored only a value exactly once and referred multiple times. Let's come to the bitwise operations. Already the bitwise operation, we already know there's a shift operation, shift left, shift right, and bitwise or. Okay, all are given here. Okay, we can see them and we can use them. All right, so the meaning remains the same. So wherever we need these operations we can apply here. So double less than, double greater than stands for shift left and shift right operation. The pipe operator stands for OR operation. We can see here. Okay, 1 or 2 leads to 3. Okay, and single and indicate the bitwise AND operation. Okay, we can perform all this one. Yeah, so yes, we can perform. We can want to see the, let's say, operation at the binary level. So this is not possible. Suppose you will already shown that you will get an error like this. Why? Because you can see this bin the of 5. Okay, so the 5 is an integer which is converted into binary equivalent, which is more like a string. Okay, we have already seen the demonstration. So let's come to this and see that, let's say I will do bin of 5. So it's more like a string. You can see that because it's a binary number. However, it is stored, okay, in a string format. That's why when we cannot apply this as an operand to the or bitwise or bit, because bitwise or bitwise AND all operate on the integer type. Okay, so this is format doesn't matter. That's why what we can do is that we can apply the OR operation 5 and 5, and the result we can see in the form of binary. Okay, that is possible, but operand of only integer type is supported for these bitwise AND bitwise OR operations. All right, so here is an example what shows that, okay, how we can apply the operation. Okay, some more examples. Let's say x is a binary number. Let's say here x equal to 0001. Okay, then we do the left shift by 2. Okay, so what happens here? So we can print the, we'll see the binary output of this, which is going to be 100 or 0100. It is shifted left for 2 times. Okay, so then we perform x and OR operation with the 010. All right, so what is going to be? So this is going to be, we can say 111. All right, and similarly x. Okay, we apply x, the AND operation with 1. Okay, so what are we going to get? We're going to get exactly just see to see the result is a 1. Okay, x equal to 0 b 0001. Okay, then x is shifted, okay, to the left. All right, so we get as integer format 4. Then we perform the AND operation with 0b 0b01. Okay, so output is 1. All right, so only the bit at the highest lowest level is 1, so we get the output is 1. So this is how we can perform the bitwise operation. Please have some examples. You can try more and more example using a bitwise operation and see the output. So the benefit here is we have a built-in function to see the output in exactly the binary format. So for other cases we have to convert. So here we can easily verify, okay, whether the operation how the operation has been performed, what is our output of the operation. Next, let's discuss about logical operators, which will be commonly used in the control structures. Okay, so there are three logical operations. We already know that logical and, logical or, and logical not. Okay, not operation. So we know the use of them. And when is and takes, okay, give the truth. Okay, all of them return a true value, and return true value if both the operands are true. Okay, or if one of them is true and not, will give the reverse. If it is true, it will give the false. If it is false, it is going to return true. Okay, so these are the, we can say, and here this time there is no operation here. Here this, yeah, these operators are just like strings. Okay, and or not. So be careful while you using them. Okay, so generally we provide a space. You can see an example here that a space and b. Okay, generally when you are using an operation like and, we don't give space. Okay, and ampersand or pipe operation, we don't give space. But here better you make sure that you give space, because these operators are strings. Okay, just a keyword, just like a keyword. So like we'll see more about in an example. Okay, so next coming the type checking. Okay, so here in Python also we have type checking. Okay, so whenever you are applying an operation, it perform a compatibility checking for the type. So see here, 2 plus 3 plus can be applied. Okay, on 2 plus 3 is fine, but when you do a string plus string, a number, wrong, because this type of operation not allowed. You can do string 2 plus 3 possible, all right, with the string. Okay, but string with the string can be used, applied with the addition operation to concatenate. Okay, however, two different type is not possible. So every time we do an operation, a type checking is also done. You will get an error if you write this kind of statement where the type mismatches for a given operation. And we'll show an example of that. Let's say we do 4 plus 5 is very clear. We'll do, let's say, 2 plus plus, let's say, 3. Yeah, wrong, must not be a string, must be an integer. It's saying that it is assuming that we are doing an integer operation, so operand should be 2. But however, if we just change this side to, let's say, 3, let's see what happens. Yes, so it accepts, because now it understands that this both the sides are string, and we are meaning for a concatenation operation. All right, so text variable. Now just when we have the previous operation 2 plus 3, then instead of plus we'll just change it to star. Then okay, then it understands. Yes, now it is looking for, we are looking for repeated printing. All right, so it every time we apply an operation, okay, it checks for the compatible types. Whenever the types are not compatible or mismatches, the Python the Python interpreter is going to give an error, the type mismatch error, type error. You will get this type error. Okay, so let's start with the first Python script. Okay, the example, I'll share the problem here. The problem is right here, and we have a program before the problem. So problem is that little Bob loves chocolate, and he goes to the store with rupees M in his pocket. The price of each chocolate is C, and store offers a discount that for every M wrappers that Bob will return back, he will get a one chocolate free. So offer is available only once, so you cannot avail multiple times. Okay, like, so for only M wrappers we will get an offer. So how many chocolates does Bob get when he has money, n rupees in his pocket? So a simple problem. Let us see the program for this. Okay, write in the script. Okay, so here is the chocolate problem, and let's see, and let us understand the script and how we can okay, fine. All right, so we need three things. First of all, how much money the Bob has, and what is the price of the chocolate, and what is the offer, how many wrappers for how many for wrappers we can get in a chocolate in return. All right, so we assign M, okay, is the money of the Bob. So we take the input the money for the Bob using M and stored in the in M, and for chocolate price stored in the variable C, and the number of wrappers, okay, is stored in the variable W. Okay, so first we, okay, as now we divide the money by the chocolate price. So how many chocolates he can get with the money M, so that is it is stored in the variable NO underscore CHO. So this computes how many chocolates he can get out of money M. Okay, so how many extra he can get? So he can get, so this many chocolates he's got it, so and he is going to get one extra per W wrappers. Okay, per W number of wrappers. So we found out the number of extra chocolate the Bob is going to get by dividing the number of chocolate divided by the number of wrappers. Okay, so this is the extra additional number of chocolates the Bob is going to get, and total equal to number of chocolate plus extra, so makes it total number of chocolate the Bob will can buy with money M. Okay, so and we print this value, and we can see that I'm using a built-in function str here. Why? Because I'm printing them as a single argument. The number of this string, the number of chocolates Bob can get, it just equals a string, and also the total, wherever, but total is an integer, maybe a floating point type here. Okay, so you can see that the total is an is a value which is holding a numeric value. So I cannot just add concatenate, as you have seen an example, a string with a number. Okay, total is a numeric type, so I have to convert that back into string so that I can concatenate this string with the string equivalent of the variable total. That's why I am applying the built-in function str, which will convert any other type into the string for type. Okay, string format, equivalent string format, so that whatever the number value the total contains, it will be converted into string format, so that we can print here and see. Let us see the output. Let's say Bob has, let's say, 100 rupees, and the chocolate price is, let's say, 5. Okay, and for every let's say 20 wrappers, you will get an extra. Okay, so number of chocolates the Bob will get is 21. Okay, is the output of the program. Okay, so we can see that a simple program which involves the operations. Okay, so this is how you can write a program with the arithmetic operations. Okay, so here is the first program which is related to the simple arithmetic operations. Okay, here now you have seen that I have not used it is division. Okay, because yeah, it should be, because it is not dealing with any we are dealing with the number of chocolates. Okay, so we can apply here the integer division instead of your floating point division. All right, so depending upon what we need, we can apply here. So here is the example. Okay, next is the salary calculation. Okay, here is an example. So the salary is, let's say, here is already been given. Okay, the salary is net salary is computed from the basic, okay, plus, okay, the additional let's say DA and HRA. Okay, so DA is 80% of the basic, HRA is 30% of the basic. Okay, all right, and we have a deduction, standard deduction for provident fund, that is 12% of the basic pay. Okay, so that makes the total salary is the basic pay plus the DA, which is the 80% of the basic pay, plus the we have HRA 30%. Okay, and a deduction, so that is to be subtracted. So it's a simple arithmetic expression, and let's see the program for that. Okay, all right, so here it is. So we take the input, the basic, because every part of other part of the salary can be calculated from the basic. All right, so we input the basic, so enter the basic of the salary. All right, that is stored in the variable basic. All right, then we calculate HRA here. Okay, yeah, little bit values are different here. I'm using it. Okay, so HR is 1% or 10% here. All right, so that doesn't matter, depend. So here I have added some new things here, like there is a fixed medical allowance here. all right. No deduction here, all right. So little bit different from the example that is discussed over there, all right. So here the HRA is the 10% of the basic, which is computed from the basic, all right. Then DA is the 75%, okay, of the basic, and a fixed medical allowance is given. So the gross salary makes the basic plus HRA plus DA and medical allowance. So okay, and it is computed and it is printed. So since this this salary is controlled the currency, so we calculate up to 2 decimal places. We'll learn how to do that, okay. But it's a we have perform all floating point operations, all right. And let's see the output. Let's say my basic is, let's say, 12,000 for example, okay. So the gross salary becomes, okay, 23,700, okay. Okay, now let's move to another the special operation, which is operator which is called lambda operator, available in Python programming, and it is very powerful, okay. So what happens that when you use a lambda operator, it can allow you to define a one line function, okay. We can say small anonymous function, okay, generally without name. So lambda in lambda operators will help you, generally meant for defining small function which can be computed or can be evaluated within one line, generally a small or a very small number of small with a small expression, okay. So which will help us to define a function and can use it whenever we need. So let's see an example of lambda here. So the syntax for lambda is the lambda, you write the keyword lambda, then what are the arguments becomes input to the lambda expression or evaluation, then a colon separates the argument and expression, and what is the expression, okay, to be evaluated. We generally use the arguments that has been provided in the argument part, okay. Let's see an example, it will be more clear. So we define, let's say, Fahrenheit to centigrade, and we denote that with a variable, let's say F2C, okay. So this become a name, a function of the name of the function. So F2C equal to lambda, then space, what is the first part is the left hand side of the colon is the argument. It takes only one argument here, let's say F, mostly okay, we can use multiple arguments, so we'll see some example. F, and the Fahrenheit is converted into centigrade by using this expression. It is well known to everybody, okay. F minus 32 by into 5 by 9 by 9, okay. So this is the we get the value. So what happens now, this lambda defines a function, okay, we can say a small one line function, okay, and the name is F2C. So and it takes one argument. So whenever we need to use it, we'll call just like a function call. So F2C 104, it is going to give you the output, okay, okay, in the centigrade, okay. Now another example, area of the circle, one line function we do, okay, we don't have to write a complete function for that. So we circle area equal to lambda, input is the radius r, and 3.14 multiplied with r and r, or 3.14 into r square, all right. So whenever we need to evaluate circle area, we'll simply use sur area, okay, a function passing the radius as an argument, and it is going to give us the result. So a lambda operator can define a one line function, okay, for small expressions, for small tasks, okay, which can be called as a inline function, all right. So here is a w square, okay, we can say, let's say a square plus b square for 2ab. So lambda, we define w square, it's a lambda wsq lambda x comma y. So here it takes two arguments x comma y and returns a square x square plus y square plus 2xy, okay. So whenever we need to evaluate, get the value of a plus b whole square or x plus y whole square, we can use this function directly. So that is the benefit of using lambda. So any what they use here, that we do not have to define a proper function, okay. So it's an inline function kind of thing, a small function, and just quickly we can define it, and whenever we need, we can call it and use it, okay. So that's the benefit of using lambda function. Then when printing the values, we may use the format specifier, as you are using the format specifier in in our C function. Okay, in a proper, when we are displaying, we want to display in a proper format. Okay, that is also possible in Python, because floating points may contain the arbitrary decimal places. We need to round them into a particular number of decimal places. So especially for the floating point numbers, we can define a format specifier, okay, specifier to show them in a proper format. Okay, so the syntax for this, the built-in function format is very much helpful, and we'll see how we can use this format function. We'll see only the very common option that is being used. Okay, for detail you can refer the python.org or any reference related to Python function format function. Okay, so I list up a little the very commonly used format specifier. So star, when you use the star, it fill up the empty spaces. Okay, after formatting. All right, it will fill up with star. Okay, so then the greater than, okay, align the output string to the right. So this indicate that it will be alignment will be to the right, and plus force the number to be signed. So when you write plus, or depend upon the sign of the number, plus or minus, that sign will appear. When you give a number like 7, okay, force the number to take minimum width of 7. Minimum 7 width will be taken. Even if the number is smaller than 7, okay, it will take say minimum 7 spaces. Okay, comma, to place the comma between all thousands. So when you use a comma over there, whenever the number is large, okay, and more in above thousands, there will be a comma between all thousands. Okay, and D, same as the our C specify, D stands for integer, E stands for the floating point number, the mantissa base format, okay, and F stands for the normal float, okay, and the caret stands that output string to be center of the remaining spaces. So here it will center it, okay, it will print in a center format. And minus force only negative numbers. If you make plus, it will force every number, whether plus or negative or positive number. But if you put negative, only negative number will be signed. Okay, and dot a number, just like the specifier in C or C++. Dot number indicate that set the precision of the floating point number up to 3 places. All right, and 0 indicate that place the empty places with, okay, place in the empty places all zeros. All right, so I will see some demonstrations here. Okay, so for print format 123D indicates that it is in the integer format. Now look at here, format 123.4567898. F indicate that it is in the floating point format. Okay, so it is floating point means it will round up to 6 decimal places, doesn't matter how long the decimal part is. All right, then B stands for binary format. Okay, and we have one, you see that 1 2 3 4 star means fill up the empty spaces with star. The greater than indicate the right alignment, plus force the sign, 7 fix the size to minimum 7 spaces. Okay, then comma, a comma after every 1000. Okay, and D for integer. All right, so you can see the format it is used here. So similarly here you can see that caret for central line, okay, minus to force the negative number, 0 to fill the empty spaces with 0, and we can see that there is a 0 at the beginning and the end to indicate that the empty spaces are filled with this. So there are 9 spaces, only 7 are used, so empty spaces are filled with 0. All right, and F stands for the floating point number. Dot 3 indicate that round up to 3 precision, precision up to 3 places after the decimal. Okay, so here how we can use the format function to print generally the floating point number or the numeric format into a display format. All right, so we can some example you can try if you want to see how the format works. Okay, and with this we'll end today's session.